Alright, I'm going to do a little bit of a video on my Flowbench and how it works and how you test the cylinder head. So here we go. Okay, so what we have here is a SuperFlow 110 Flowbench. This was one of the first, if not the first model. I think the first model was a SuperFlow 100. But this is a 110, which became probably our biggest selling flow bench that SuperFlow ever had. And it was useful for testing all types of cylinder heads. And I'll explain a little bit about how it actually functions. So in the back of the bench, it's got some motors, vacuum cleaner motors, that are used to suck or blow air through the bench and through the test orifice, which in most cases would be a cylinder head. The knobs down here, this turns it on. This selects whether or not you're going to be sucking air through the intake or blowing air out the exhaust. This adjusts the flow pressure for testing on the intake side, and this adjusts the flow pressure for testing on the exhaust side. The vertical manometer that you see there, it goes from 0 up to 16 inches of water. That is what you use to set your test pressure. And the incline manometer, the scale, which was a proprietary scale specifically to SuperFlow benches, tells us the percentage of flow pressure based on what we're using for a test pressure. And then these holes up here on the top change whatever range. You can have different combinations of them. This one's covering number 1. We never provided corks, pull it off, for the number 1 hole. Anyway, that's what sets the range, and this chart down here on the bottom is telling you what the flow would be in each range. So if I was just using the number 1 orifice, the one with the test piece of tape up there, and you had a max flow on this incline manometer of 100%, you would be flowing 10 CFM of air, okay? If you're on range 2, that means if I just had the hole number 2 open up there and I had 10 inches of water here and I had this flow at 100%, I would be flowing 18 CFM, and so on and so forth, all the way up to 185 CFM if I had all those holes up there on the top open, and this was at 10 inches of water. So it was a pretty good test device. This chart, along with this incline manometer and their percentage scale, is really going to tell you how much air you're flowing through whatever orifice you're testing, in most cases a cylinder head. This apparatus here, this is a plexiglass cylinder head adapter that we sold for testing V8 cylinder heads mostly. It was really designed for Chevy small blocks, but anything else, you know, big blocks, didn't matter. You could mount your head on this. It's got 2 different orifices. One on the bottom is bigger than the one on the top. And then I've got this piece of wood on here for testing, using a smaller orifice here, just to get it a little bit closer to what I'm testing. And I needed to be able to seal around my cylinder head, and you'll see that here when I bring the cylinder head over here and get it all mounted up. It plugs in down here to 115 volt AC, and that's all there is to it. It's a pretty simple design. The bench itself is made out of plywood, and then we had to put Formica on it to seal it, because it turns out pretty much any kind of wood, regardless of what kind of sealant you use on it, has a certain amount of leakage. And when you're testing here, you really want to have no leakage whatsoever. When you turn the bench on, you begin to flow, you don't want to be reading flow that's coming from air passing through the wood, air passing through leakage around the cylinder head adapter. That's why this foam tape is all on here, foam tape here. you want to be able to test only the flow going through the device that you're testing. And like I say, you'll see that here when I get everything mounted up. Oh, you might have noticed the temperature gauges. So since this device, the way SuperFlow designed it and made it, it doesn't matter what altitude you test at, the density of the air going through the bench and through the orifice remains consistent, because we have the barometric pressure won't make any difference. However, on this particular bench, because the air flows through the bench and heats up as it's flowing, that changes the density of the air just a little bit, so we make a correction based on air temperature. Really doesn't make much difference with the with the humidity of the air. We never really bothered to make adjustments based on that, but we do make adjustments based on the temperature differential between the orifice and where the air is coming into the bench, atmospheric air temperature. So, all right, so that's kind of it for how the bench is designed and what it's supposed to do. I'll get my cylinder head mounted on here, and we'll perform some tests today. I'm doing a Honda CBX 6-cylinder head, and I've got one of the cylinders, number 2, already flowed, and I still got 5 more to flow. So, and it's 4 valves in each head, so the setup gets a little complicated, but I'll go ahead and get it mounted up and set up, and then I'll show you how to actually perform a test. So I thought I'd show you this test orifice plate. We would ship a test orifice plate with every flow bench, and you'll notice this big hole here and the little hole down here. Okay, so what you would do without this cylinder head apparatus on here, you'd mount this on your bench and you would flow it, and if you had both those holes open, the spec was at 10 inches of test pressure. The intake flow through the 2 open orifices there would be about 81% on the incline manometer. And then if you did the exhaust, the spec was 83%. And then what you were supposed to do is you flowed this, and you would see what you read for the test when you performed it, and then you'd make an adjustment. You can see there I have some numbers on here, 28 May 25. My actual on the intake was 82.5 instead of 81, and my exhaust was 78.5 instead of 83. All that means is my bench wasn't flowing perfectly to spec, and if I really wanted to advertise and sell my flow numbers, I would make a correction factor based on how far off my bench flowed on this test plate versus what the spec was. You know, if it was a couple % off, then I'd make that adjustment before advertising my flow numbers. Now, I'm not advertising my flow numbers. I don't care. I'm just looking at how my flow numbers compared to my cylinder head when I tested it before I cleaned up the ports, and now I want to know what it looks like after I cleaned up the ports. And I didn't do a whole lot of work on the ports. I just cleaned up a little bit of ridges around the bowls and smoothed out some edges on the intake and exhaust runners. But other than that, that's what this plate would be used for. It would come with every bench, and you would use it to test your bench and really make an adjustment in your numbers based on how your bench tested versus what the specification was. And these orifice plates are very precise. That's a square-edged orifice. That is not a rounded drilled hole. It's a square-edged orifice because a square-edged orifice has a different flow characteristic than a rounded or drilled hole. So that was very important how we had these made. All right, so when you put your valves in to do testing, I got the intake, there's the exhaust, or no, this is the exhaust, and this over here is the intake. You got to use small springs, because if you were trying to put your regular valve springs in there, you'd never be able to depress the valves to do the test. So we use these small springs, and then I'll put the retainers on, and that's what we'll use when we're actually testing it. So. All right, you can see this is the intake side. I got the retainers in place, and same over here on the exhaust side. And you can push the valves down. That's because I got the little springs on there. If you had these springs on, you'd never be able to push anything down. Okay, so as you can see, my cylinder head's pretty long, and I'm trying to do this first port here. I got this clamping the head down, and that clamping the other part of the head down. So next thing we'll do is we'll check for leakage. So I'll turn the bench on, and I'll check to see if my valves have sealed. You got to make sure you got a spark plug in the hole, which I do, and I'll test it on the #1 range up there where the piece of tape is, and we'll run it on. And this is the exhaust port, so we'll do the exhaust, and we'll turn the bench on, and we'll see what kind of leakage we have. I'll go ahead and set that up, and then I'll show you what I'm talking about. Okay, so my valves are closed. I have test orifice 1 open. Okay, so that puts me on the lowest range down here. So if I were to get 100% on this scale, I would have 10 CFM of flow. I have my manometer zeroed, and my vertical manometer is zeroed. I have the intake flow all the way closed. I have this in the exhaust position. I have this all the way closed. Now we'll turn the bench on. And I'll open up the flow, and you'll see the water manometer rise. So I'm at 10 inches of water. And I got about 35%. Okay. See that? Getting a reflection there. So 35% of 10 is 3.5. So I got 3.5 CFM of leakage, which is pretty acceptable. It's almost impossible to have no leakage at all, and some of that's in my bench itself. It's not leakage here on the test apparatus, but you can see how I got it all clamped down. And then I don't know if you can see up underneath there, you can see the valves are basically exposed in that port up there. So now we'll set up for measuring the opening of the valves. I'll be doing the exhaust valve first, and we'll show you how that gets done. Okay, the next thing you got to do is you got to have an apparatus so that you can open your valves, and you can open them to certain increments. We use 50 thou increments to open them. So I took a piece of flat bar stock steel, drilled holes and threaded it. Then I have these, I think they're number 10 screws or whatever in there, a fine thread, so that I can adjust them. I've got the shim buckets and the shims in place to hold the valves down, so that I can use that to push the valves down, up and down. And the next thing we do is we'll put up an apparatus so we can measure how far we're depressing each valve, so that we know that we got the same increment, so that when we test we have our flow numbers at various increments. Okay, so I test my valves at 50 thou increments, and I'm going to go all the way up to 300 thou fully open. So what I'm going to do is I'm going to crank them down to 300 thou, both valves, and then I'll back them off 50 thou until I'm all the way back to 0, and I'll do my tests. So you can see I've got like 47 thou here, and so I'll go to 97 thou and continue to keep going. I'll go all the way to 300 in my increments. The increments on this particular dial indicator are 1,000th for each mark on there. Okay, so I got a heavy steel block here, and I got a magnetic base dial indicator, and I got my dial indicator down here on the valve. And so what I'll do is I'll open that valve to 300 thousandths, and then I'll move it over to the other valve and open it to 300 thousandths, and I'll do my first flow test. Alright, if you look in there, you can see my valve is open. The other one in there is closed, and you can see it's depressed. Okay, so I'm going to move this over to that valve, and I'll crank it into 300 thousandths as well. Alright, hopefully you can see inside there. I'm not sure if you can, but both valves are open. You can see up there. They're open 300 thou, and that'll be my first test. So this is going to probably flow somewhere around 62 or 3 CFM. So on my chart down here, I'll be using range with numbers 1, 3, and 4 open, and at max flow is 84 CFM. So you can see I got hole number 1, number 3, number 4 open, and we'll get ready to do the flow test. My upper temperature is about 60 degrees, and my lower temperature is about 60 degrees as well. So we'll go ahead and do our flow test. I already have it set up to give me the proper test pressure. I'll turn the bench on. You'll see what the incline manometer will do as the vertical manometer increases. So we're at 10 inches over here. We're at 66. 66 on the Flowbench. Temperature is up to 70. Temperature up there was 60. So the temperature down here is 70. Temperature up here is 60. So there's a difference because it's bringing the air from the outside in, flowing it through the vacuum cleaner motors, pushing it up and out my ports. So it heats up when it does that. And that's why this one shows the temperature change up. It's getting hotter. Okay, you saw the test pressure come up to 10 inches, which is the spec that we're using to do our test with, and the incline manometer, whether you can see it real well, reflects on here. It went to 66%. So 66% of 84 CFM is what my flow is. Okay, this is a sample of a SuperFlow test data sheet, and it's what you would record all your data on. It's got a lot of stuff on here. You could do a lot of prediction stuff and all kinds of things. I'm not using it. Instead, I'm actually using a spreadsheet that the owner of the company, Neil Williams, built back in a long time ago, probably in the 70s or 80s. Maybe the 80s, maybe the 90s, he built this spreadsheet. But anyway, I had used this spreadsheet to test my cylinder head before, so I'm using it again now. And here's where I logged my test data. My base temperature went up to 70, my top temperature was 60, my flow percentage was 0.66 or 66%. And the max flow on that range was 84. So it's figuring out that I've got a flow of 52.3 CFM. And on that particular cylinder, the exhaust valve flowed before. It only flowed 47.8. So I picked up some flow on the exhaust port side on that particular cylinder number 1. All right, as you can see, testing cylinder 6 on the intake side, and I have my dial indicator on here to show how far down I am and how far my valves are open, and I do it on both valves to get both of them equal, and then I flow it. So let's see what happens here. 10 inches of water, and we're flowing at 98%. Temperature here is 72. Temperature up there is about 85. Okay, I finished all the testing on the cylinder head, did all 6 cylinders, and put all the data into my spreadsheet and computed the results. Now, as I said earlier in the video, I didn't do a whole lot of port work on this cylinder. Basically just cleaned up around some of the bowls, cleaned out some ridges and smoothed some things out. Generally that doesn't result in a whole lot of change in your flow characteristics. So I'm going to show you the two graphs. These are composite graphs showing all cylinders combined, and it shows all for the intake side and all for the exhaust side. And you'll see that I didn't really gain a whole heck of a lot. The exhaust seemed to gain more at high lift, lost a little in middle portion and low lifts, and then on the intake, the only place it really gained at all was at the maximum lift of 300 thou.